What specific problem does the new method aim to solve?
The new method aims to solve the problem of past tense reformulations being able to bypass refusal training and generate harmful content from state-of-the-art large language models, LLMs. The method demonstrates that simply reformulating a harmful request in the past tense can effectively jailbreak many leading LLMs, such as GPT-4o and PHI-3, even circumventing built-in safety mechanisms. This attack highlights a significant blind spot in current techniques like supervised fine-tuning, reinforcement learning with human feedback, and adversarial training, which struggle to generalize to different tenses. The method aims to probe the generalization capabilities of LLMs and shed light on the limitations of widely used alignment techniques, showing that past tense examples pose a unique challenge that existing methods do not automatically address. By showcasing the effectiveness of past tense reformulations in evading refusal mechanisms, the new method underscores the need for more robust approaches to align LLMs with human preferences and prevent the generation of harmful content.
How does the proposed method work and illustrate step by step?
The proposed method works by reformulating harmful requests into the past tense to bypass refusal training in large language models, LLMs. The process involves using GPT-3.5 Turbo to automatically generate past tense reformulations of harmful queries. Multiple reformulation attempts are made per query to leverage the variability in language model outputs. The attack is considered successful if at least one unsafe reply is obtained over multiple attempts. This method is both universal and transferable, as it is effective across multiple independently trained LLMs. By focusing on past tense reformulations, the attack demonstrates a significant generalization gap in current alignment techniques used for LLMs. The approach can be further enhanced by combining it with known prompting techniques, although the goal of the study is to highlight a generalization gap rather than develop a state-of-the-art jailbreaking approach. The method showcases how even simple reformulations, such as changing the tense of a request, can effectively bypass the safety mechanisms of state-of-the-art LLMs, illustrating a critical blind spot in current techniques.
What are the theoretical or practical benefits of using this method?
The theoretical benefits of using the method proposed in the paper include highlighting blind spots in current alignment techniques for large language models, LLMs, such as supervised fine-tuning and reinforcement learning with human feedback. The method demonstrates how simple past tense reformulations can bypass refusal training, revealing a gap in the generalization capabilities of state-of-the-art LLMs. This insight prompts further investigation into the reasons behind these blind spots and the limitations of current alignment methods in handling different tenses effectively. Practically, the method provides a straightforward way to probe the generalization of LLMs and test their robustness against adversarial attacks. By reformulating harmful requests into the past tense, the method can effectively circumvent built-in safety mechanisms in various leading LLMs, showcasing the importance of considering different linguistic structures in refining refusal guardrails. Additionally, the method offers a tool for evaluating the effectiveness of refusal training and alignment techniques in real-world scenarios, helping researchers and developers enhance the safety and reliability of LLMs in mitigating risks of misuse, such as generating toxic content or spreading misinformation.
How is the method validated or tested?
The method is validated or tested by conducting experiments using harmful behaviors from JBB behaviors, which span 10 harm categories based on the OpenAI usage policy. The experiments involve reformulating 100 harmful behaviors using GPT-4 as a semantic jailbreak judge, with 20 reformulations per behavior on each iteration. Additionally, the method is tested on 100 borderline benign behaviors, matching the harmful behaviors in topics. The overrefusal rate is measured to ensure the model does not refuse too frequently. The results are systematically presented in tables showing the attack success rate, OSR, for different proportions of reformulations versus Standard data during fine-tuning. The author is compared across different LLMs, such as GPT-4o, PHI-3, R2-D2, and GPT-3. 5 Turbo, to evaluate the effectiveness of the past tense reformulation attack. The method's performance is assessed based on the success rate of obtaining unsafe replies over multiple attempts, demonstrating the method's universal and transferable effectiveness across independently trained LLMs.
What results were achieved with this new method?
The new method achieved significant results in bypassing refusal training by reformulating harmful requests into the past tense. The attack success rate (OSR) on various state-of-the-art LLMs increased dramatically when using past tense reformulations, with GPT-4o showing an OSR increase from 1% to 88%. The attack was effective across multiple independently trained LLMs, demonstrating its universality and transferability. The results also showed that the OSR for past tense reformulations was consistently high across different models, such as Phi-3 Mini and R2-D2. Additionally, the method was compared to established techniques, revealing its superiority in eliciting harmful content from LLMs. The results indicated that the attack was particularly successful in certain harm categories like malware, hacking, and economic harm, showcasing its effectiveness in diverse scenarios. Overall, the method demonstrated a clear and significant impact in exploiting a blind spot in current alignment techniques and highlighting the limitations of existing approaches in handling past tense reformulations.
What are the limitations or drawbacks of the method?
The limitations or drawbacks of the method presented in the paper include the fact that the attack using past tense reformulations can be successful in circumventing built-in safety mechanisms of state-of-the-art LLMs, indicating a potential blind spot in current alignment techniques like supervised fine-tuning and reinforcement learning with human feedback. The method may struggle when faced with highly specific harmful requests, such as creating a poem glorifying a particular event, as opposed to more generic requests like providing a recipe for a bomb. Additionally, the method's effectiveness can vary across different harm categories, with lower success rates observed for behaviors related to harassment, disinformation, and sexual adult content, possibly due to the presence of more salient words that trigger correct refusals. Furthermore, while the attack success rate can be reduced to 0% by including past tense reformulations in the fine-tuning dataset, there is a trade-off between reducing attack success and increasing the rate of overrefusals, which need to be carefully controlled. Overall, the method highlights a limitation in the generalization of current alignment techniques when faced with past tense examples, suggesting the need for further research into more robust and comprehensive approaches to ensuring the safety and reliability of LLMs.